So in today's lecture, we will be starting with a new topic, which is kinematics. So we already gained some proficiency in vectors. We already gained some proficiency in calculus. This is enough to go ahead with this discussion on kinematics. So let us start this topic. Please remove all the old things from your mind. Things like I already know this topic, I am bond of kinematics. Please remove all these ideas, because if you don't focus on what I am saying, you will again go wrong. You will not be able to solve the problems which I will give you, because I will be again building this topic from basics and it's going to be completely different. So every topic in physics and this topic also addresses certain problem. So every topic in physics addresses certain problem. So what is the problem of kinematics? What are we trying to solve by learning this topic? Addresses certain problem. So problem of kinematics is this. Problem of kinematics. You are given some information in the form of kinematical quantities. We will see what kinematical quantities are. So you are given some information about a moving body, okay, which we generally call as a particle. In physics we use this term particle. Particle is an object of zero size. It can have some mass. It is an idealization, okay, it is an idealization. In practice there is no such thing called particle, but anyway, you are given some information about a moving body called particle, and we have to find position time relation of the particle. Position versus time relation of particle. This is the whole problem of kinematics. Because if you know position and time relation, you can, by doing some operations, get velocity time relation. You can get acceleration time relation. From there you can get force, and you can know everything about the object. So if I know this position time relation, you can predict at what time where the particle is, what is its velocity, what is its speed, what is its acceleration, what is the force acting on it, everything you can predict. So our ultimate aim in kinematics is to find position time relation of a particle. If already this is given, sometimes in problems this is given, and you are asked to find velocity time, acceleration time, etc., those kind of problems are not very tough, they are very easy. But in majority of the problems, this position time is not given, something else is given. Maybe acceleration time relation is given, maybe velocity time relation is given, maybe acceleration velocity relation is given. So we don't know, some weird information will be given. You should find this position time relation. That is the whole problem of kinematics. In order to solve this problem, there are some definitions which we have to understand. So the problem of kinematics is to get position time relation for a particle or for a moving object. To understand, to find this position time relation, we have to understand certain definitions. So there are some basic definitions in kinematics. We have to understand them, and you have to be very, very thorough with them. First we will talk about distance traveled. This is the first quantity we will look at. Very simple, quite easy. Second, we will look at position vector and displacement vector. This is the second important thing. Then we will talk about average of certain quantity. How to calculate average of certain quantity. For example, average speed, not an easy task, this can be very complex. Or average velocity, how to calculate average for certain quantity, that is what we will see next. Then we will talk about velocity and we will talk about speed. Finally, we will talk about acceleration. Then we shall derive some special relations. We shall derive some special relations among kinematical quantities if acceleration is constant. Under that special case, we will derive some relations. From there, we will go into one-dimensional motion. We will first discuss 1D. Then we will go into 2D. Then we will go into 3D if necessary. Now and then, sometimes we encounter 3D motion also. So that is our strategy. So let us first start with these basic definitions. All the definitions that I am going to give are very general. Very general. It doesn't put any restriction on the type of motion. It could be 1D motion or 2D motion or 3D motion. But the definitions which I am going to give are general. So we'll start with the first quantity, which is the distance traveled. So let's talk about distance traveled. Distance traveled. In the first instance itself, I want to tell you, distance traveled, both are different. That's why my course is going to be different. Okay, first of all, you should understand the difference between distance and distance traveled. Anyway, let us first continue with distance traveled, then I will talk about distance. Distance traveled by a particle is defined as length. So basically it is length of the path covered by the particle or traveled by the particle, covered by the particle. So essentially you are talking about the length of the path. So in whichever path it goes, you must measure the length of that path, and that gives you distance traveled. That gives you distance traveled. Of course, it is a scalar quantity. It is scalar quantity, and SI units, we take meters. If the distance is more, you can measure in kilometers. If it is even more, you can measure, for example, the astronomical distances in light year, etc. If it is at a smaller scale, you can go into millimeters, micrometer, nanometer, etc. That is at a smaller scale. These are the units. So mostly we will stick to meters most of the time. It's a scalar quantity. That means if you want to add two distance travels, there is no point in discussing the direction here. So you just take those two lengths and add it up to get the total length. Now, why I am stressing on this point that it is a scalar quantity, that is one, and distance traveled, second important point. One is distance traveled is a scalar quantity. This is a very important thing. I'll tell you the reason why this point is important. And distance traveled cannot decrease with time. This is a very important point. With time it can only increase or it can remain constant. It cannot decrease with time. Now, why these 2 points are very important? Scalar quantities, most of them, not all, majority of scalar quantities cannot take negative value. There are some which can take, please understand, that's why I said majority. There are some that can take negative value, but majority of them. So in the case of distance traveled, it cannot be negative. Distance traveled cannot be negative. This is a very important point. We will see what is the importance of this soon. This is one point. Then distance traveled cannot decrease with time is another interesting point. Why these 2 points are important? These points are important in graphs. For example, if I gave you a distance traveled versus time graph, which is like this is not possible. Simply, this is not possible. The reason is, here distance traveled is negative. You see, these are the points where it is negative. So S cannot be negative. Okay, that's the speciality of distance traveled. It cannot be negative. Then distance traveled cannot decrease with time. Suppose you traveled 1 kilometer in certain time. After that you stopped. If you continue to stay there only, you traveled 1 kilometer. Or if you continue to walk, you would have traveled more than 1. But can it be less than 1? You already traveled. How can it be less than 1? Simple. So distance traveled cannot decrease with time. That means if I have a graph of distance traveled versus time, which is like this, not possible. Because it has been increasing with time, but from this point it is decreasing with time, not possible. So distance traveled cannot be negative, cannot decrease with time. What about a graph which is like this? Okay, it is not negative, it is, in this case distance traveled is positive, but is this graph possible? No. Because the problem is, at a given time, at a particular time, there are 2 values of distance traveled. How can that be? Either you traveled, so if somebody asks you a question at 3 o'clock, up to 3 o'clock how much you traveled, you should say only one answer. I walked 10 kilometers. You can't say 2 answers, because the total distance traveled, there can be only one answer. But in this graph, at a particular time, there are 2 values of distance traveled. So this kind of graph not possible. This is not possible, not correct graph. Reason is very simple. At a particular time, there cannot be 2 values for distance traveled. At a particular time, there cannot be 2 values for distance traveled. So that's why all these points are important. Now coming back to our original discussion, I said distance and distance traveled are different, because distance can mean distance between 2 objects. Distance between 2 objects. It can mean distance between 2 objects. This can decrease with time. You see, suppose the distance between you and wall was 500 meters initially. After some time it is only 250 meters. It can decrease, because you are not referring to distance traveled, you are referring to only the distance. So this can decrease with time. That's why this quantity is quite different from distance traveled. So distance is different, distance traveled is different. Distance traveled is a kinematical quantity. This comes in kinematics. Distance does not come in kinematics. It comes in daily life or in some other world, but at least in physics we are not very much interested in distance, at least in kinematics. We are only interested in distance traveled. So distance can mean distance between 2 objects, whereas distance traveled, it is the length of the path covered by a single object. There are no 2 objects which we are discussing in distance traveled. It is the distance traveled or length covered by single object. So distance traveled is length of the path, So first thing is, it is defined as length of the path covered by particle or object. This is a scalar quantity. Scalar quantities, there are scalar quantities which can take negative value, so there are some scalar quantities that can take negative value. For example, work done by a force is a very beautiful example. Work done by force, this can take negative value also, but it is a scalar quantity. Okay, now to give you a better understanding, all vector quantities can take negative values. Very important statement. All vector quantities can take negative values. Why? Negative value simply means that the direction of that vector is opposite to your chosen positive direction. Negative value for a vector quantity simply means that the vector points opposite to your chosen positive direction. Simply your chosen positive direction. This is the meaning of a vector quantity taking a negative value. So all vector quantities, no exception, can take negative value unless you put some restriction, or there is some restriction specifically somewhere. They can take negative values. Scalar quantities depends. Some can take negative value, some cannot take negative value. For example, distance traveled cannot be negative, it is a scalar. Speed cannot be negative, it is a scalar quantity. Work done by a force can be negative, it is a scalar quantity. Current, it has direction, but it is not a vector quantity, it is a scalar quantity because it doesn't add as per the rules of vectors. Current is a scalar quantity, it can take negative value. If you say minus 3 amperes is flowing in a wire, nothing wrong. Minus 3 amperes flowing in certain direction is same as 3 amperes flowing in opposite direction. Okay, for example, if I take a wire, if I say minus 3 amperes is flowing in this direction, that is equivalent to saying 3 amperes is flowing in this direction. Okay, but the currents do not add as per vector rules. Suppose if I have a current carrying wire carrying 3 amperes, another current carrying wire which is put like this 4 amperes, and this is a wire, let us say this is 90. Do you think 5 amperes will go here because these two are perpendicular? No, 7 amperes will go. They don't add like vectors. So it's a scalar quantity. So current, even though it has magnitude and direction, does not add according to the rules of vector addition, does not follow rules of vector algebra. Okay, hence it's not a vector quantity, it's a scalar quantity. So that you keep it in mind. So distance traveled, I have told you to the best of my ability. Distance traveled is defined as length of the path covered by the particle. It's a scalar quantity. SI units are meters generally. You can go for a bigger unit like kilometer, light year, etc. Or smaller units like millimeter, micrometer, nanometer, etc. Distance traveled cannot decrease with time. Very important point. It can only increase or remain same. For example, I can have a graph like this between distance traveled and time. This kind of graph is okay. Initially distance traveled is increasing, means the person is moving. Later distance traveled is constant, means the person has stopped moving. Simple. As simple as that. So this is okay. This kind of graph is okay. But this graph is not correct because distance traveled cannot be negative. Here it is being shown as a negative value. And this kind of graph is not correct because distance traveled cannot decrease with time, but here it is decreasing with time. This kind of graph is not correct because there cannot be two values for distance traveled at a particular time. There should be only one value. Okay, you cannot be at two places simultaneously. If you have that ability, then you can say distance traveled is having two values, but that is only possible for yogis, at least not for us in our current world right now. Okay, and all vector quantities can take negative values. Not only that, all vector quantities can decrease with time. You remember this also. All vector quantities can decrease with time. Can decrease with time. So we are going to look at these points later when we go into displacement and other things. So this is as far as distance traveled. So how will you measure the length of the path? If it is a curved path, you can measure the length with a rope. If it is a straight path, collection of many straight paths, you can take a scale and start measuring distance traveled. For example, if a particle is going like this, then like this, then like that, you can take a scale, measure each of these lengths and add it up to get distance traveled. Or if it is going in a curved path, you can take a thread or a rope and put it on that path and later measure the length of that thread or length of that path, which is called distance traveled. So no big deal. Now let's come to the other definition, which is position vector. We'll first look at position vector. From there I will take you into displacement vector. So the real thing in physics is starting from here, and later we'll take up average and other things. So let me erase these things now. So let's talk about position vector. This is a very important quantity in kinematics. In kinematics, before you do any problem, you should have your coordinate system fixed. What do you mean by coordinate system fixed? You should have shown your x and y axis or z axis also sometimes with origin. Okay, whenever you do any problem of kinematics, before you even start the problem of kinematics, you should tell where is your origin, what is, in which direction is your x axis, in which direction is your y axis, in which direction is your z axis also if it is a 3D problem. Without mentioning coordinate axis during problems, though we sometimes do, okay, because sometimes they are very easy, but strictly speaking, okay, strictly speaking, doing kinematics without mentioning your coordinate system is a crime. Doing kinematics without drawing or mentioning coordinate system is crime. Okay, that means you have not understood kinematics thoroughly. Simple. Without choosing coordinate systems, if you start doing things, you will have so many problems where you will go wrong. As simple as that. You should first tell what is x axis, what is y axis. Okay, once you fix that, then you can talk about position, displacement, all things. Now once you fix the coordinate system, suppose there is a particle somewhere. This is a particle. Okay, what is a particle? An object of zero size or a very small size, a sand grain, you can say. It is a very good approximation of a particle. So the sand grain is there somewhere at some point. The vector joining the origin of coordinate system to that particle, that is called position vector. Vector joining origin of coordinate system means this to that particle, that is position vector. So this is going to be position vector. I can put an arrow on it. Okay, I can put an arrow on it. So vector joining origin of coordinate system to that particle is called position vector of that particle. That is what we call as position vector. This position vector has got a magnitude, the length, and it's got a direction also. We generally use the alphabet R to denote position vector, and you put a bar on that. Some people write it like this, R. I am used to writing it like this, whichever way. Preferably we use small letters. You can use capital, I don't mind, but we denote it with the letter R. In physics, at least in kinematics, R, if you write like this, immediately persons will say that it is a position vector. So position vector has got some magnitude and direction. Now let us go to displacement vector from here. I told you about position vector. Suppose if you have particle at some other point, then the position vector will be different. Position vector can be written in terms of components also. How? See, if you look at this position vector, I can split it into a vector along x-axis and a vector along y-axis. How? You should drop a perpendicular onto x-axis. Then one vector is this, that is the x component. We generally write its length as x. This is the y component of the vector. Let us say its length is y. So this position vector can be written as xi plus yj. So this is the x component of position vector. I use the variable x to represent x component of position vector. X component of position vector. And this is y component. What about z component? Generally in physics we are discussing up to 2D, we discuss very freely. If it is a 3D motion, you have to include z component also. So if the object is moving in a plane, then only two components are enough, x and y components. But if the object is moving in a space in 3 dimensions, then x, y, z components are needed. First, let us deal with the simpler case of two components, object moving in a plane. So this is y component of position vector. Y component of position vector. Okay, so we generally represent it with R. X component of R is written as x, y component is written as y, z component of R can be written as z. So in a more general case, if you want to discuss, R is written as xi plus yj plus zk. This is for 3D. What I am discussing here is for 2D, 2 dimensions. 2 dimensions means particle moves in a plane. 3 dimensions means particle is moving in a space. Okay, so position vector, either you can write it as R or you can write it in terms of components xi, x units along x-axis, and yj, y units along y-axis. I is unit vector along x-axis, j is unit vector along y-axis. We already saw this in unit vectors topic. Okay, magnitude of this position vector mod R, if it is 2D, you can write it as root x square plus y square. This is the magnitude of position vector. If it is 3D, you can write it as mod R is root x square plus y square plus z square. One thing you should note, position vector is basically nothing but a coordinate. Can you see that? You can also tell in mathematics that this point is denoted by x comma y. X is its x coordinate and y is its y coordinate. So you see, coordinate geometry and vectors are related topics. Let me tell you 4 topics which are related. You will later learn them in detail in mathematics, but this logic of mine will help you. Coordinate geometry, this can be related to vectors. This can be related to complex numbers, which we will learn later. This can be related to even trigonometry. You will be surprised. These topics are interrelated. Sometimes it is possible that a problem given in coordinate geometry can be done in a very simple way with vectors or with complex numbers or with trigonometry. Sometimes a problem in vectors can be done easily if you know some formula of coordinate geometry. Sometimes a problem in trigonometry can be easily done with complex numbers or vectors. So these are all related topics. Okay, I don't know whether you will learn about this in maths or not, but this is a very important thing. At least in my JEE preparation, I was going through all that. Anyway, so how is trigonometry coming into a picture? Because if you say this angle is theta, then this length will be r sine theta, and this length will be r cos theta. So I can write this vector r as r cos theta I, because r cos theta is along x axis, plus r sin theta j. So you see how I got trigonometry into picture. What is your x? It is actually r cos theta only. What is your y? It is r sin theta. And later you will learn in complex numbers this can be written as r into e power I theta. You will learn it later in complex numbers, or r cis theta. Okay, that I am not going to reveal it now. It's a deep secret. You will learn it in complex numbers. So this is about position vector. So position vector is simply a vector joining origin of the coordinate system to the particle. So obviously position vector depends on your choice of coordinate system. Very important point. Okay, so obviously position vector depends on choice of your coordinate system. So if two persons choose two different coordinate systems, even though the particle is same, the position vector of that particle for those two persons is different. For example, let us say a particle is here. This is a particle. One particular person has chosen coordinate system like this. Another person has chosen a coordinate system like this. So for this fellow, position vector would be this. Okay, I can put an arrow, and for this fellow position vector is this. So for each person position vector is different. You see, both the length and direction are also changing. So you can say this is position vector r. For this coordinate system it is r prime. So position vector could be different for different persons. That is very natural. Suppose there is a car near your house, a beautiful car. For you its position is something. For your friend in America, the position of the car is something different. It is very far away from him and in a different direction. So obvious. Now let us come to displacement. Let us come to displacement. Now we are looking at displacement. Displacement is also a vector quantity. Displacement is a vector quantity. You can define displacement in two ways. Definition: it is a directed line segment joining initial and final points. This is one way you can define displacement. Directed line segment, not a simple line segment. Directed line segment joining initial and final points. Or it is change in position. Change in position means, what does change in position mean? Change in position means change in position vector. Change in position means change in position vector. Change in position vector. Change always means final value minus initial value. Please remember this. Final value of a quantity minus initial value is called change. So now let us look at it. Suppose this is my coordinate system. Okay, a particle was initially here, and finally after some time it has moved in some complex path. It could have moved in a very complicated path, and after some time it is here. So the particle went from A to B. I want displacement vector. So you can define displacement vector as follows. Displacement vector is a directed line segment. First you should join the initial and final points with line segment. So we join it like that, and then you put a arrow, directed line segment. So that is displacement vector. Okay, why displacement is important? See, suppose you saw a person at A, then you went to sleep, then when you woke up you found the person at B. What do you say to your parents? The person got displaced. Okay, So if they ask you how much he got displaced, you will tell this length, right? That's why it's called displacement. You are not concerned with how the person actually moved. You are sleeping when he moved and you don't know even how he moved also. But when you woke up, you found him at a different position. For example, you have your dog. You gave instruction to your dog that, hey, sit there, I am going to sleep. And the dog sat. But when you went to sleep, it is a mischievous dog and it went into some other place. Maybe it went into kitchen, did some mischievous stuff and came back and sat at another place. When you woke up, you will see the dog to be displaced. Okay, so it was at A and now it is at B. So it got displaced by some amount. That length is called displacement's magnitude. The direction is of course the direction of displacement. So displacement is a directed line segment joining initial and final point. So I can write the displacement vector here as AB. This is another way of writing vectors. If you know the starting point and ending point of vectors, if you have given some naming to those points, you can show vector with the starting and ending point and an arrow. Of course, you could name it as A or B or S or whatever, but this is also another way to represent vectors. So this is the displacement vector, directed line segment joining initial and final points. But you can also define displacement as change in position or change in position vector. Position means position vector. Please understand this. Position always means position vector. Position by definition is a vector. So how to define that? What is the initial position? Let us check what is the initial position. Initial position is a vector joining origin to the initial point where the object was there. That is initial position. I must put arrow, I will put it. Final position is this. Okay, this is the initial position, this is the final position. Let's say this point is O. So I can write Ri. I refers to initial. Okay, I refers to initial. I can write Rf. F refers to final. Change in position means final minus initial. When you subtract from final initial, don't you get AB? Don't you get AB? How? How? Let us check it. Is R final minus R initial AB? I am asking this question. Let's check it. Okay. If it is, then R final must be AB plus R initial. Is it correct? AB R initial is this vector plus AB is giving you R final by triangle of vector addition, because R initial is this vector. At the head of that vector I am putting displacement vector AB and adding it to get RF. So RF is AB plus RI. That means what is AB? RF minus RI, change in position. So displacement can be defined as change in position, final position minus initial position. Okay, so either you can define displacement as a directed line segment joining initial and final point, or you can define displacement as change in position. When you are finding displacement, it is immaterial how the object moved from that initial to final point. It could have moved in any complicated path. I do not care. I am not interested in that complicated motion. I am only interested in the displacement, how much it got displaced. So obviously here I can tell you, in this example which I have shown, okay, in previous page particularly. Where is the previous page? Here, in this example. Magnitude of displacement, which is mod AB, magnitude of displacement is less than distance traveled, is it not? Is less than distance traveled. Magnitude of displacement is this length. Is it not less than this length, the distance traveled? Correct. So magnitude of displacement is less than distance traveled. In general, I can write like this. In general, magnitude of displacement is a general statement. Magnitude of displacement is less than or equal to distance traveled. This is a complete statement. Okay, when will the equality hold? Some people say, sir, when a body moves in a straight line, see the mistakes people make. And IIT gives you such kind of questions where you have to be very precise. Suppose a body moves in, or I will use the better word, a particle moves in a straight line. Then displacement equals distance traveled. Displacement equals distance traveled. B. Okay. Is the first statement correct? Wrong. First statement is wrong. Simply because displacement is a vector quantity. How can you equate it to a scalar? First mistake. This is a vector quantity, whereas distance traveled is a scalar quantity. How can you compare? You are equal to your dog. Is it a good comparison? You are a different kind of species, it's a different kind of species. You are a human being and it's a dog. How can you be equal? Lot of differences are there. Biological differences are there, intellectual differences are there, spiritual differences are there. How can you be equal? So this is not correct. Many people use this kind of statement very loosely. So displacement is distance traveled, sir. Wrong. You do not know physics simply. You simply do not know physics. You have not understood vector quantity and scalar quantity. First mistake. Okay, suppose if you refine this statement, magnitude of displacement, okay, equals distance traveled. This is a better statement than previous one. And particle moved in a straight line. So is this correct? Again, need not be correct. You have to be very thorough. Need not be correct. Why this need not be correct? Simply because suppose I am here, I went like this from A to B and came back to C again. I moved in a straight line only. Don't you think it is a straight line? I went from A to B and back to C. Is it a straight line or a curve? It is a straight line. Is magnitude of displacement equals distance traveled? What is the displacement? This is your initial position. This is your final position. This vector is displacement and magnitude will be that length. Whereas distance traveled is this length. How can both be same? So this is not correct. So when will the equality hold? When is magnitude of displacement equal to distance traveled? Answer: when particle moves without changing direction, matter ends. When particle moves without changing direction, that's it. Simple answer. So when particle moves without changing direction, then magnitude of displacement equals distance traveled. In all other cases where particle is changing direction, distance traveled is more than the magnitude of displacement. Okay, so I talked about displacement. You can define it as either change in position, okay, or a directed line segment joining initial and final positions, whichever way, both are fine. This is about displacement. Now displacement, because it being a vector quantity, displacement can take negative values. It's possible. Suppose you took this as positive x direction. Body started from here and reached there after some time. So displacement is this way. It is opposite to your chosen positive direction. So displacement is negative. Suppose if magnitude is 3 meters, I can write minus 3i is the displacement. Why minus 3i? Because it is pointing along negative x-axis, opposite to your chosen positive direction. You see that negative sign? So displacement can take negative values, no big deal. Displacement can decrease with time. Displacement can decrease with time, which means I can have a graph of displacement versus time. This is displacement, not, I use the same symbol S sometimes for displacement's magnitude and distance traveled also, but we must be very specific. This is a displacement. This kind of graph is okay because displacement can take negative values, no big deal. Or even a graph of this kind is acceptable because initially displacement was increasing, then displacement is decreasing. How? Suppose you started from here, you are going, displacement is increasing, you are coming back, displacement is decreasing. When you come back to starting point, displacement is 0. Okay, I should not show it like this also. I should go and come back in the same path, but that will be at least visualistically you cannot identify, so I am showing it like this, but this is wrong actually. This is the correct way. You started from here, went same path, you are coming back. Is it fine? And you reached the starting point. So displacement can increase with time and then start decreasing, can become 0, can become negative also. You might start going in the other direction. The other kind of graph which we discussed for distance traveled, something like this. This is again not possible here. This graph is not possible. Simple reason, at a particular time you cannot have two values for displacement. At a particular time you are here also, you are there also. So that is not possible. You cannot be at two places simultaneously at a given point of time. So this kind of graph is not possible anyway. Is not possible. Okay. In mathematics, you will study these kind of graphs. These are non-function, not functions. This cannot be a function. A function, there are some specific rules for a relation to be called a function. You will study in mathematics. So this kind of graph is not a function. Okay, you will study about those technicalities in mathematics. So I talked about the distance traveled, displacement, position vector, these three things. Now is the time to go into average of a certain quantity. Very important. Average of certain quantity. How do you calculate average of a certain quantity? Very important question, very deep thing, not easy. This you should never forget. This is very important. Many people will forget this. They won't be revising notes again. This is the problem. You have to be very thorough here. You can't afford to miss this. Whether it is a vector quantity or scalar quantity, I don't mind. The quantity could be a vector quantity or a scalar quantity. It doesn't matter. The basic principles are same. See, if it is, there are two types of quantities. Quantities apart from vectors and scalars, vector quantity and scalar quantity, you can also distinguish a quantity as discrete and continuous. Discrete means it will take certain values, some fixed values. Continuous means all possible values. Let me give you an example. Population, human population, dog population, etc. It is discrete. There can be 10 people, there can be 15 people, there can be 20 people, 22 people. Can there be 22.5%? Now this, it cannot take this value. It can take only certain fixed numbers. Okay, population can be 1%, 2%. Between 1 and 2 there are so many numbers which population cannot take. Okay, whereas if you take height of a person, it can be 1 meter, it can be 2 meter, it can take any value between these. The person could be growing in height, so it will take all possible values from 1 up till 2, because when he is growing in height, at every moment there will be one position reached. So here height can take all the values, so it is a variable which can take continuous values. Height can take continuous values, population can take discrete values. So you can have quantities which are discrete and which are continuous. In childhood, you have been told how to calculate average of a discrete quantity. Okay, you can calculate average of a discrete quantity. Very simple. Suppose there are 4 students, student 1, student 2, student 3, student 4. This fellow has 3 chocolates, this fellow has 2 chocolates. Okay, this fellow has 4 chocolates, this fellow has 6 chocolates. If you want average number of chocolates, what do? This is a discrete system. So you add all these, 3 plus 2 plus 4 plus 6 divided by number of persons, that is 4. So it will be 15 by 4, that is the average. Okay, this is the average. This is how you calculate average of discrete system. You simply add, divide by the total number of such units. Okay, you add the content in each unit, you add the number of chocolates for each person, divide by total number of persons, you got average. This is how you do it for discrete system. For continuous systems, now comes the important point. For continuous systems, average will be calculated using integration. That's why this topic is tough. Instead of addition, you can add. For discrete systems, you can put a plus symbol. The same addition for continuous systems is called integration. So adding lots of terms, infinite number of terms, is integration. So integration is addition only, but addition of infinite terms. So now let's come to average. How I calculate? Obviously I am interested in the average of continuous systems here. Discrete system average, you know how to calculate. So I am interested in calculating average value of continuous systems. This is the first point. Okay, then the average that I am going to calculate is called time average, because in physics time is the independent variable. The average that I am going to calculate is called time average. There is something called space average. I will not go into it right now. Later when the time permits, if needed, I will go through that. Time average. Let me take the best example that I gave you long back in calculus. Baby's height was changing with time as h equal to t square. So at t equal to 0, baby's height was 0. At t equal to 1 second, baby's height is 1 meter. T equal to 2 seconds, baby's height is 4 meters. Fast growing baby. This example we saw in calculus. Do you think the baby is growing in a continuous way or discrete way? At 0.5 seconds, don't you think there was some height for baby? Yes. At 0.25 seconds, there was height. At every moment, there is some new height for the baby. So baby is continuously growing. It's a continuous function. Suppose I asked you, find average height of baby from 0 to 2 seconds. Average height. How will you do it? Not easy. First you should plot a graph between height and time. So the graph will look like this in this case. So you see, from 0 to 2 seconds, the baby is taking so many heights, so many values of height. All these values it is taking, is it not? So many values. This is 4. This is 4 meters. It is taking so many values of height. All these values average you have to calculate. How will you calculate? The idea is, now in this case, how do you get the average? First you find this area. Okay, this area. Average height is that value of height which, if it were constant for the same time, if it gives same area as this area, that is called average height. So look once again, average value of height is that value of height which is fixed, which is not changing. Let us say, suppose if the baby had certain height for 2 seconds, same height, the area of height versus time for this constant graph and this variable graph, if both are equal, then that constant value of height is called average. That means I have to equate areas here and here. What is the area here? Integral h dt from 0 to 2 seconds. What is area here? H average into 2, base into height. Both areas must be equated. So integral 0 to 2 h dt is h average into 2, or average value of height becomes integral 0 to 2 h dt by 2 minus 0 or 2. So I will now generalize this. Average value of a quantity q from t1 to t2 seconds, from t1 to t2 seconds is given by integrate that quantity with respect to time from t1 to t2 divide by the time difference. This is the average. That is the average value of q. When you put two brackets like this, it is called average value. That is read as average. These two brackets means average. So how do you calculate average of a quantity? First of all, why are you wanting to calculate average? Because that quantity is changing continuously. It is changing. With the time it is changing. Okay, in physics we take quantities which change with time. So that quantity is changing with time. So I first integrate that quantity with respect to time from t1 to t2 and divide by time difference. Okay, that will give me the average. For example, in the case of h equal to t square, suppose I want average height from 0 to 2 seconds. Integrate height from 0 to 2. What is height? It is t square. Divide by the time. So this will give me t cube by 3 from 0 to 2 by 2 minus 0. 8 by 3, okay, by 2. So 4 by 3 is the average height from 0 to 2 seconds. 4 by 3 is the average height. That's how you get it. If you are doing initial height is 0, at t0 height is 0, at t2 seconds height is 4. If you do 4 plus 0 by 2, you are wrong. That answer is wrong. It's not correct. That's not average height. Why that's not average height? Because initially baby was growing slowly, later baby was growing fast. So for most of the time the baby's growth rate is slow, most of the time. Only in the last half or last part baby's growth rate is high. So average value, so most of the time height was small only, it was not big. So average cannot be just 4 plus 0 by 2, it will be 4 by 3, it will be less. Okay, so once again, how am I getting the average? Look again, if there is a quantity which is changing with time in some fashion, so that quantity, for example, at t1 seconds, that quantity takes this value q1, at t2 seconds, that quantity takes this value q2. So average will be somewhere between q1 and q2, no doubt. It will be somewhere between q1 and q2, average. If you want average from t1 to t2, it is taking so many values, but it will be somewhere between q1 and q2. So how to get that? First you find this area. Okay. Now if there was average value of this quantity, fixed value, that graph with time, the fixed value never changes. That fixed value which gives the same area from t1 to t2, as this area, that fixed value is called average. So that fixed value of the quantity which gives same area from t1 to t2 as this, that fixed value is called average. That means you are equating this area with this area. What is this area? It is given by integration of q dt from t1 to t2. What is this area? It is simply the area of rectangle, that fixed value or average value into t2 minus t1. So take this term there, you get average. So average is integrate the quantity with respect to time and divide by time. So what are you getting as average? Integrate the quantity with respect to time and divide by the time difference. This gives you average in that time. Okay. I will give a better example to make you understand this, and after that we will have a break. Suppose a particle is going with a speed t square meters per second. See this. Particle's speed is continuously changing. At t0 speed is 0. At t1 speed is 1. t2 speed is 4. Every moment speed is changing. Okay, suppose I want average speed from 2 to 6 seconds, let us say. So let us plot a graph. Speed is changing with time like this. At 2 seconds speed was 4. At 6 seconds somewhere here speed is 36. Is it right? So many values are there. 4 to 36, so many values are there. You must take average of. Okay, how to get that? First we find this area. What is area under speed time graph giving you? We will see later. It gives you distance traveled. Speed integrated over time gives you distance. We want distance from 2 to 6 seconds. Total distance by what is total time? 6 minus 2, 4 seconds. Total distance by time is average speed. Na? This is a better example. You can relate it. Okay, this area is distance traveled, area under speed time graph. Now how are you getting average? If you are going with a constant speed for same time and you are traveling same distance, instead of so many speeds, choose one speed such that you will cover same distance in same time. That speed is called average speed. Suppose you went from here to your house with different speeds. Suppose your house is 6 kilometers, you reached in 1 hour. You went with different speeds. But what is your average speed? 6 km per hour. If you had gone with 6 km per hour without changing, still you would reach in 1 hour only, na? So that constant value of speed, if you still go for the same time, whatever distance you cover, even with changing speeds you are covering same distance, that constant value of speed is called average speed. That's why we are focusing on the constant value which gives same area with the time as the variable value. Okay, so simple. If you do not understand all this, my idea is simple. Average of q is integrate q with respect to time. You want average from which time to which time? t1 to t2. If you want from 0 to t, put 0 to t by t2 minus t1. Average velocity is velocity integrated over time from t1 to t2 by t2 minus t1. This is giving you average the time interval t2 to t1, t1 to t2. Suppose I want average acceleration. Integrate, suppose I want from 0 to t seconds. Integrate from 0 to t adt by t minus 0. It doesn't matter whether this quantity is a vector quantity or this quantity is a scalar quantity. It doesn't matter. Any quantity, average is calculated like this only. So for a vector quantity, if you want average, vector quantity integrated over time divided by time, that is average. Scalar quantity, if you want average, scalar quantity integrated over time divided by time, the time interval. So you are getting average in the time interval actually. These limits tell you what is the time interval in which you are calculating the average. If you are calculating average from 0 to t seconds, you get average value in 0 to t interval. Okay, average value can change depending on time interval. So this is about average of a quantity. So I hope you understood this. We'll meet after the break.